Hello guys, this is a new Leetcode question called lucky numbers in a matrix. Okay, so here we are given a matrix of m by n, m cross n matrix of distinct numbers. Return all lucky numbers in the matrix in any order. A lucky number is an element in the matrix such that it is the minimum element in its row and a maximum of in its column. Okay, yeah. So we are given a matrix here called 3, 7. Okay, wait. Okay, we are given a matrix 3, 7, 8, 9, 11, 13, and 15, 16, 17. Okay. Uh, in this, the we have to find the lucky number. We have to find lucky number. Okay, in this matrix. So in this lucky number is a number which is minimum in its column and maximum in its row. Okay. So here, as we can see, the in the first row. Okay. In this first row, 3 is minimum. In the second row, uh, 9 is minimum, and the third row 15 is minimum. Okay, now we have to find the maximum, so in this column, because it is the minimum. Okay, so as we can see, 15 is the maximum in this column, so answer will be 15. Okay, but there's a twist here. Okay, uh, suppose wait a minute. Yeah, in this matrix, suppose we are if I'm giving this given this matrix. Okay, and here the minimum will be. Okay, the minimum will be 3 here in the first row. For the second row, it will be 9 minimum for the row. Okay, and third row, it will be 15. Okay, and if we see for the columns, 15 will be the maximum here, and 16 will be maximum here, and and both can be a lucky number because 15 is minimum in this row and maximum in its column. 16 is maximum in its column. So there is a confusion because between 16 and 15. So we can assume not it's we can say that we will take only 15, only one lucky number, because only 15 is satisfying its condition that it's greater in its column and smallest in its row. Okay, greater in its column, and 16 is only satisfying one condition, and there can be only one element that is minimum in its row and maximum in its column. Okay, so let's take an example of sorry, let's take a second example. Okay, let's second example. mm, let it be let it be uh, 1, 10, 4, 2. Okay, and 9. Let's change it format. 8, 3, 7. Uh, then it will let us take 15, 16, 17, and 12. Okay, here we can see 1 is the minimum for its row. Okay, and 3 is the minimum it's for this row, and 12 is the minimum for this row. Okay, and for the maximum in this row, it will be 15. Okay, for maximum in this row, it will be 17, and for maximum in this row, it will be 12. As you can see, 15 is uh, maximum and not minimum. So 15 is maximum, not minimum in this row. Okay, 12 is maximum and minimum both. Okay, so we can just take this first. We cannot take 15 because it's not minimum in its row. We cannot take 1 because it's not maximum in its column. We cannot take 17 because it's not minimum in its row. We cannot take 3 because it's not maximum in its column. Okay, so only 12, and there can be only one number in every matrix that is lucky. Okay, so let's see the code. Yeah, this is the code. Let's remove it. Let's do it from scratch. Okay, so I'm taking a maximum. Okay, r max. Okay, and it will be float minus infinity for getting its infinity value. Okay, we are doing this because we need to find the minimum of the elements from the row first, and then we'll find the maximum elements of the minimum row. Okay, from all the rows. Okay, let's compare the column and minimum. Okay, column and row. Yeah, so we will iterate for suppose m in matrix. Okay, uh, wait a second. Yeah, that will be. Then our minimum, the minimum rows will be minimum of m. Okay, and then we will find r max, the maximum from all the rows. Okay, so it will be max of r max, comma r min. Okay, then we will iterate to the next matrix. Okay, for m in matrix, I mean, sorry, my bad. Let's say I for I in range matrix of 0. Okay, we have to now iterate the columns first. Okay, so we will make c minimum is equal to float, uh, yeah, float minus, so float infinity. Okay, because we need to find the maximum element first, and then we'll compare it to the row. Okay, so it will be like c max is equal to max of uh, matrix j and I for j in range, our j in range matrix, length of matrix. Okay, and then we will find a minimum. C minimum is equal to minimum of c minimum, comma c max. Okay, we are doing this because we will first find the minimum of its column. Okay, and we'll compare all the things, and we'll find the maximum elements out of it. Okay, from all the rows. Okay, then we'll do the vice versa. Okay, we'll first find the column maximum from the columns, and then compare with the minimum of it, and compare both the rows and the columns. If both are the same, then it means that it is the lucky number, because we are just cross verifying it using cmax. Okay, we are again finding it, so that if we are finding the maximum column and minimum of it will be the row. Okay, row element from one row. Okay, and similarly, like in row, we are finding a minimum element and finding the max element from each rows, from the minimum of from the each rows, we will get a maximum element of that row. Okay, so it can be a column, or in the column it can be a row. Okay, so we'll just compare it. If c minimum equal to uh, r max, we'll just return our c minimum in list. Okay, c minimum, else we'll just return we cannot find it. Okay, else return this. Let's remove the else, we'll make it simpler. Very simple. Okay, yeah, let's run it. List can be interpreted as integer. Okay, array, we want to find length. Yeah, as you can see, it's taking 41 minutes again. Yeah, yeah, it's one to optimize. Let's see that same complexity. Yeah, n into m. M is the number of columns, and n is number of rows. Okay, yeah, it is good now. It's a good complexity. Okay. If you have any other like better approach, please comment down below. Thank you.